హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు జిఎంకే ట్యూటోరియల్స్. ఇప్పటివరకు ఎవరైనా మన ఛానల్ ఇంకా సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్. ఓకే, so let's go to the topic. So previously we discussed two topics regarding the two-port networks point of view, that is nothing but Z parameters are also called as a open circuit parameters. Second one is nothing but Y parameters. It is also called as a admittance parameter. Now we are going to discuss in third one is nothing but a hybrid parameters. Okay, so hybrid parameters. Hybrid parameters. So hybrid parameters, it is the third one. It is also called as a H parameters. Hybrid parameters is also called as a H parameters. So these parameters are very important, plays a very key role in the electronic circuit analysis topics. Okay, it is very plays a very important role with. So why we are calling it is a H parameters or hybrid parameters? So basically in the Z parameters we are using the open circuit parameters. It can be represented in the form of a Z parameters can be represented in the form of a like Z parameter represents the V1 comma V2 format, as well as admittance parameters Y parameters can be represented as a I1 I2 equations format. Now it utilizes the both Z parameter concepts as well as the Y parameters concepts. That's why it can be represented in the form of a V1 and I2 format as well as I1 and V2 format. So that's why it is called as a hybrid parameters, because of it utilizes the both open circuit as well as the short circuit parameters. So that's why it is called as a hybrid parameters. Now these hybrid parameters can be represented in the form of a matrices format is equal to V1 into I2 format. So V1 is the open circuited parameter, I2 is the short circuit parameter. Therefore it utilizes both these two. Therefore is here H parameters can be represented as H small h, H11, H12, H21, H22. Okay, as well as this is also represented in the form of a V1 I2 is written now in the this can be represented in the form of a I1 V2 format. Okay, it can be represented as a I1 V2 format. Okay, therefore now it can be represented in the functional formats. V1 is equal to function of I1 comma V2, as well as I2 is equal to function of I2 is also function of I1 comma V2, right? This is just a functional representation. Now from these equations we can write down the equations for V1 is equal to H11 into I1 plus H12 into V2, as well as I2 is equal to from this equation I2 is equal to H21 into I1 plus H22 into V2. Let us consider equation number 1 and 2 in this case. Okay, not for previous cases, just you will consider H11 and 2 for these two equations. Now if you want to find out the H11 and H12 and whatever it may be, just you have to take the one of the parameter must be 0. Okay, so for that purpose, assuming first one is nothing but I1 is equal to 0. I1 is equal to 0 means a short circuit. Okay, so assume that short circuit conditions at the output and V2 is equal to 0. Okay, therefore short circuit at V2 is equal to 0. Short circuit at output port. So therefore it gives rise to V2 is equal to 0. V2 is equal to 0 means that V2 is equal to 0 means that just you have to see here V2 is equal to 0 is also called as output port, right? Okay, short circuit, that means short circuit means that output port is equal to 0. Short circuit means that output at a short circuited port output voltage must be 0. Therefore from this equation what we are getting here, V1 is equal to H11 into I1 plus H12 into 0, as well as from the second equation also I2 is equal to H21 into I1 plus H22 into 0, right? These are the two equations, right? So from this equation, what we are getting here? So from the first equation, v1 is equal to h11 into I1, that is equal to h11 is equal to v1 by I1, one equation, right? So from this equation, what we are getting here? I2 is equal to h21 into I1. From this equation, we are getting h21 is equal to I2 by I1. Okay, I will give the names for this one later, right? So it is in the form of a V1 by I1, means that it is in the form of a resistance, right? Impedance. Therefore, it is a forward impedance. We can call it also forward impedance, because of V1 by is called as a forward impedance. V1 by I1 forward impedance or input impedance. And the second one is nothing but what we are getting I2 by I1. I2 by I1 means that output side. So it is a gain, current gain. Therefore, it is also called as a forward current gain and input impedance. Forward current gain and input impedance. Forward current gain. Okay, I2 by I1 is nothing but forward current gain and okay. So there is a names for this one, guys. If you want to represent the corresponding name from this circuit diagram only, we can write. So let us see. V1 by 1 is nothing but a forward, right? Input impedance. Okay. So it is I2 forward current gain, because of I2 by I1 is nothing but gain, right? Forward current gain. Next one, then you have to find the next what we are getting. I1 is equal to 0. I1 is equal to 0 is nothing but output port. When output port is equal to 0, then only there is a possibility. Okay, therefore, so for the second consideration, write on the point here, that is nothing but when input port is open circuit at the time I1 is equal to 0. When I1 is equal to 0, what happened? What we are getting here? V1 is equal to H11 into 0 plus H12 into V2, as well as second equation. So from this equation, how can you represent this one? So V1 is equal to H12 into V2. Therefore, H12 is equal to V1 by V2. Okay. Now, second one is nothing but from the second equation. What we are getting here? Second equation is nothing but from this. Just I will mention here. I2 is equal to H21 into 0 plus H22 into V2. So from this equation, how we are going to represent? I2 is equal to H22 into V2. So from this one, H22 is equal to I2 by V2. The names for this one, how we are going to represent the name of this one? I2 by V2 means that actually admittance. Therefore, it is called as a, so I2 by V1 called as a reverse and output admittance. First, this is called as a output admittance. So this is generally V2 by V1 is called as a gain of the voltage gain. Then V1 by V2 means a reverse voltage gain. We can call as a reverse voltage gain. Okay, these are the very important, guys. H parameters or equations are H11, H12, H21, H22. So how we are going to represent this one? H11 is equal to H11 is equal to V1 by I1. This is called as a V1 by I1, as well as when we are getting calculated when V2 is equal to 0. Therefore H1 by V2 is equal to, then we can represent as H12. H12 is nothing but what we are getting, V1 by V2, V1 by V2 when I1 is equal to 0, as well as H21 is equal to what we are getting, H21 is equal to I2 by I1, I2 by I1 when V2 is equal to 0, as well as H22 is equal to V2 by H22 is equal to I2 by V2 when I1 is equal to 0. Now what are the naming convention for this one? How are we going to represent one? I2 by V2 is equal to output admittance. Okay, this is nothing but forward current gain. It is a current gain actually. Just try to understand because of the forward current gain. So V1 by V2 is equal to reverse voltage gain. Reverse voltage gain. This is nothing but V1 by V1 is nothing but forward impedance. Forward or input impedance. These are the H parameters for the hybrid parameters. Okay, these are the very important, guys. This is a very important concept for analyzing the electronic circuit analysis also. Okay, so these are the topics in H parameters. If you want to find out the reciprocity conditions, just I don't want to give I don't want to go through this one very clearly. Just I will mention the conditions for the H parameters. That is nothing but H parameters condition is nothing but H is equal to, for reciprocity condition, what we are getting is equal to H12 value is equal to H12 value is equal to minus H21. This is nothing but reciprocity condition. Reciprocity condition of H parameter, as well as for if you want to calculate the symmetric condition, that is nothing but H11 and we can call as a delta H. Delta of this one is equal, must be equal to, that means that H11, H12, H21, H22, this value must be equal to 1, then only it satisfies the symmetric condition. Okay, this is the one more important thing in the H parameter. If you want to analyze this equation, you have to go through this one. In the equation number 1, you can put V2 is equal to 0, you can get only one equation. Similarly for the second pattern also, you can get you have to calculate by I2 by I1. I don't want to give I don't want to go through this very clearly, just you have to, if time being, just I can mention the equation. When V2 is equal to 0, what we are getting, V2 is equal to 0, what we are getting here is V1 is equal to H11 into I1. So from this, what we are calculating here, H11 is equal to suppose if you want to calculate H11 is equal to V1 by I1, right? So let us see in the previous case, if you want to find out V1 by V2 is equal to H21, I2 by I1, right? I2 by V1. Just if you are taking the just to take the current directions also very important. I2 by I1 is also outward direction. From this also we don't want to, not an issue. So okay, fine. Just I don't want to go through this one very clearly. Okay, if the time being, just you can go through this one. Just I will write down the direct equations. I2 by I1 is the I2 by V1. Sorry. just I will draw this one first clearly, right? See guys here, just I will write down the equations. I2 by V1 is equal to minus H21 by H11. You will get one equation from this one, as well as thus from H parameters representation I1 by V2 is equal to I1 by V2 is equal to what we are getting here is H12 by H11. So if you are taking and V1 and V2 are equal, V1 and V2 are equal, those two may be equal. Okay, those two may be following principle, left side of the equation both are same. Therefore, it satisfies the condition as reciprocity, that is nothing but H21 is equal to minus of H12. This is a reciprocity condition for H parameters. Okay. So thank you for watching GMK tutorial guys. Thanks a lot.